In this video, I'm going to show you guys how to make your very own 3D camera from scratch for your OpenGL project. Making a 3D camera for the very first time can be difficult due to how mathy it could get. But the purpose of this video is to help walk you guys through how to make a camera from scratch and actually help you guys understand what's going on behind the scenes. So, let's jump right into it. So right before we hop into the code, I want to talk about our end result. So if we hop into a vertex shader, which I'm assuming you guys already know how to make a shader, we see a bunch of lines over here. However, the most important line here is line 16. I'm going to go ahead and highlight that. So as you guys can see, there are three major things happening here. So here there are three matrices called transform, view, and projection. And it's important to understand that you can't really have a 3D object on a 2D screen. At the end of the day, we are just rendering 2D triangles that look 3D to the human eye. So the way we do that is distort these vertices in such a way to make them look 3D. And so basically this equation right here is what does all that math, just in one single line. That's all. So everything is happening here. So if we take a look at the transform matrix, what we're doing is we're multiplying it by the current vertex that we're processing. So the current vertex that we're processing in our mesh is going to be multiplied by a transform. The transform consists of the position of the object, the rotation, and the scale of the object. This will help the object fit into the world. Next up, we have the view matrix. The view matrix is the camera matrix. It's what we're going to be focusing on this tutorial. But what it essentially does is it takes any point and simulates a camera. And what that would do is it would simulate whether something is inside of the camera's field of view or not. Because we all know we can't see everything at once. We can only see a certain amount. The only way we can see something behind us is by turning around. And that's what the view matrix does. Next up, we have the projection matrix, and this is another simple matrix that just applies perspective. So nothing is truly 3D unless it looks 3D. And the only way something can look 3D is if it's farther away, it gets smaller. And so yeah, so those are these three matrices in a nutshell. But in this video, like I said, we're going to be focusing on the view matrix because that's the camera matrix, and this is a camera tutorial. So, real quick before we start implementing this, I want to show you guys JAML. JAML is a cool math library that helps us do all this magic. Now, obviously, JAML is not going to help you make a camera, but it deals with all that matrix and vector math behind the scenes. Now, of course, if you're really confident in math, you can take a challenge and do all that math from scratch by yourself. But since we're programmers, we are not mathematicians, let's go ahead and get JAML. So to get JAML, you're going to want to go to the LWJGL website, and then once you're here, you're going to want to go to download. Once you go to download, we see this page, but if we go on browse files, and we go to add-ons, we see JAML. And if we go in here, we just have to select the jar files that we need. Now, I'm not going to pick up these jar files right now because I already have this library installed into my project. But yeah, and by the way, if I didn't mention this earlier, JAML stands for Java OpenGL Math Library. So yeah, good to know, in case you wanted to know. Alright, so let's start implementing this. Okay, so inside my project, we have a first-person camera class, which will do all the math to make this camera work. So as you guys can see, I already imported some classes from JAML. Now, before we start touching this class, if we go over to main, I already kind of set out an outline of how this camera class should be. So the very first thing this camera class should have is a basic constructor. So we should be able to pass in a XYZ coordinate for the camera's position. Every camera has a position, and we need to be able to pass that in. Then we need a function to set the look direction. So let me explain. When you move your mouse, typically in video games, the camera moves around. You look in different areas. And so basically, that's what this function is going to be responsible for. Now, a camera isn't a camera unless you can move it around, and that's where the translate function comes in. And finally, last but not least, we have the getMatrix function, and this function will return the matrix. And that is the matrix that we're going to be using inside of this shader right here to get our final results. So with that in mind, let's go ahead and start making this class. So very first thing we're going to want to do is make some vectors. So I'm just going to make some private vectors here. We'll call this one position, one for which way the camera is looking at, and one vector that just specifies which way the camera is facing. So typically in most games, this vector is going to be 0, 1, 0, the y being 1, x and z being 0. This just specifies that the camera is facing upright. Now, let's make a constructor that initializes all these variables. So if we head back over to our main, you guys can see we should be able to pass three numbers here that are the XYZ coordinates of our position. So let's go ahead and make that happen. Alright, great. So I made myself a simple little constructor here. And all we have to do is initialize this vector right here. So JAML is a really intuitive library, just like you would expect from any math library. So to initialize this vector, it will be quite simple. We will just want to say new vector 3f and pass in our xyz coordinates. Perfect. And if you guys are wondering what this 3f means, the 3 stands for 3 components. So there's a x, y, and z to this vector. The f means they are all floats. Alright, great. So next up, we want to initialize this look direction. So by default, when we create our camera, we want our camera to look forward. And it just so happens to be that the forward direction in any 3D space is -1. So the z direction has to be -1. And so although it might be more intuitive to be a positive number, if it was a positive number, it would be facing backwards towards us. And we wouldn't want that. So let's go ahead and initialize this one as well. Perfect. And let's go ahead and initialize orientation. And like I said before, orientation is going to be 0, 1, 0 because that just specifies that the camera is facing upright. It's not upside down or anything. Alright, so great. We made ourselves a basic constructor here. But now we're going to want to translate our camera. So you might wonder, how do we do that? And it actually is really simple. So if we head back over to the first person camera class, let's make ourselves a new method. And we'll call it translate. And it will take in a x, y, and z. Perfect. Alright, so from here, we're just going to want to increment position. So position is the position of our vector, our camera, and the only way we would move it around is by incrementing its values. So let me show you what I mean. We can just say position.x and add it onto x, and we'll do the same thing with the other ones. Simple, huh? Well, that's all we need to do to translate a camera. So next up, we have set look direction. So this function is going to be responsible for making the camera look around in different directions. And you might think this will be one of the more difficult functions to implement, but it's actually quite simple. So if we head back over to the camera class, let's go ahead and make yet another function. And we'll call it set look direction. And this time it's going to take in two values, a x and a y. And the reason for this is because we're going to want to take in our mouse coordinates. So let's go ahead and write float x and float y. There we go. Now when it comes to rotating a camera, we need to introduce two new variables. So let's go up here and I'll talk about them as we go. So the first variable is going to be called the yaw. And some of you guys may be familiar with this, but if you aren't, don't worry. Yaw basically is an angle in degrees or radians, but typically degrees because that's more intuitive. But essentially, we use yaw to determine how much the camera in degrees should rotate in a certain direction. So say we wanted to look to the left by 30 degrees. Our yaw angle must be 30 degrees for our camera to rotate 30 degrees. So by default, we're going to set this equal to 0. And obviously, if we want to look up and down, we have to have another variable that controls that. And typically, this variable is called pitch. And we'll set this one equal to 0 as well. Alright, perfect. So every time we move our mouse, these two variables will get updated and we'll use these two variables to rotate our camera. Great. Alright, so from here we want to set our yaw and our pitch equal to the mouse coordinates. So to do this, we're going to have to say yaw equals x and pitch equals y. Now from here, we have to actually rotate our vector that we defined in here. Luckily for us, JAML provides an easy way to rotate this. Now if you weren't using JAML, you would have to get into some trigonometry and use sine and cosine, but luckily, if you are using JAML, this is quite easy. So it's important to remember that when it comes to rotating, there's types of rotations. There's rotations about the x-axis and rotations about the y-axis. Rotations around the y-axis make our camera look left or right. Rotations about the x-axis will make our camera look up and down. So when it comes to the yaw angle, we want to rotate our camera about the y-axis. So let's go ahead and do that. So we'll type in the name of our vector and we'll type in rotate. Make sure I spell it correctly here. And there we go. And it takes in our angle. Now again, this angle is going to be in radians, so this won't be correct. So we need to make sure this converts to radians. So we can just say math.to radians. And radians actually returns a double, so we need to cast this into a float. Perfect. Now, to make sure the changes are actually applied to this vector, we want to pass in this vector as an argument right here. Alright, so from here we're going to want to do the same thing for pitch. And this time we're going to want to rotate around the X. And this will help the camera look up and down. Alright, so this is great, this will work. However, there is unfortunately just one problem. The problem is if we go into our main class, and this problem is more relative to my project. It might not be the case for your project. But if we go ahead and take a look at this, every frame we pass in this variable. So let's say our X position of our mouse was 400, right? Every frame we pass in 400. Now let's go to the camera class. Yaw is always going to be 400. So every frame we're rotating the look direction by 400. And so if we were to run this, our camera would be constantly spinning really fast. In simpler terms, we only want to rotate our camera when there's the offset. Or in other words, when we move our mouse. So to do this, for my case, there's an easy solution. We can just make two new variables. And we'll let them be floats. And I'll call this last mouse X. We'll set this equal to 0, why not? We'll do the same for the Y. Perfect. And what we're going to want to do is set this equal to X and set last mouse equal to Y. This way, if I go over here and I say minus last mouse X, and I do the same thing for the Y, it will only get that offset. So between frames, if I move my mouse, it will take that offset and that will be the yaw for that frame. Alright, so I feel like I'm over explaining this. Hopefully you guys understand. If you guys don't, you can always leave a question in the comments. I'll do my best to answer. But there's one last function that we need to implement. And that function is getMatrix. So getMatrix is that function that takes these three vectors and cooks it up into that matrix that we've been talking about. So let's go down here and let's go ahead and make a new function. And this time we're going to want to return a matrix 4f. Now a matrix 4f is just a 4x4 matrix and the f stands for floats. So it consists of floats. We're just going to call it getMatrix because that's a good name for it. And then here we're just going to initialize a new matrix. We'll call it matrix. Set it equal to a new matrix. So from here, what we're going to want to do is call a function called lookat. Now the lookat function is a very popular and important function, and it's used by like every camera in every video game. And it's basically the function that compiles all these vectors, all this data into that matrix that we've been talking about. So to call this function, we just have to say matrix.lookat. And right away, right off the bat, you can see it takes up three vectors. The first one is called I. Now I is going to be the position of the camera. So we already made that vector, so we can just pass in position. And let's go ahead and make sure I spell that right. The next parameter is going to be the point at which the camera is looking at. Now, it's important to note that this is not a direction, this is rather a point. Now for now, I'm just going to pass in look direction. However, you'll see that this won't work. The last parameter is that orientation that specifies which way the camera is oriented. We'll just pass in orientation. And as a last optional parameter, we'll pass in matrix to apply all these changes to matrix. And we can go ahead and return that. Alright, perfect. Let me go ahead and fix this. Alright, so as I said, this won't work because this function takes in a point, not a direction. So you might ask, what's the problem with the point? And the problem is, if this is our point, right? 0, 0, negative 1. And I'll explain this to the best of my ability. But let's say we have a camera somewhere up in the sky. So the camera's Y value is really high up. That means the camera has to look down to look at this point. And so we would be looking down, not forward. And if the camera's Y value is some negative number, so the camera's down below, the camera would actually have to look up to look at this point. So instead of looking forward, like I said, it would look up. And so we can't deal with this situation in this way. So how do we fix this? The solution is actually really easy. All we have to do is just add this vector by position. And so let's go ahead and do that right now. So I'm going to go ahead and make a new vector. We'll call it point, or a better name would be look point. And we'll set this equal to a new vector. And from here, we just want to initialize each of these values. Let's go ahead and do that for the y and z. So I know this might look a bit complicated, but all we're doing is we're just taking the look direction and we're adding it by position. What this essentially does is it makes this look direction, this direction, relative to where the camera is. So even if the camera was somewhere up in the sky, that means this look point would be somewhere up in the sky. So relative to the camera, we would be looking forward. And so from here, we are basically done with our camera. Simple, right? This is all the code we needed to make a camera. And I also did realize I made a silly little mistake here where I put these two lines above these two lines right here. So these should actually go after these two. There we go. And if you guys think about it, it should make sense why I put it after these two. But if we had it before these two, no matter how much we moved our mouse, the camera would never move because X and last mouse position are equal to each other. So this would always be 0. Anyways, the camera class is looking done, and this is actually all we needed, believe it or not. So not a lot of code at all. Now before we run this, I want to tell you guys that throughout the gaps of this recording, I actually stumbled upon a better and cleaner solution to moving our camera around. So as you guys can see, right here, we are literally creating another variable over here to store the previous frame's mouse coordinates. But instead, an alternative is to literally just copy these two lines and paste them over here. And this way we can just put in a look point over here. And we can just get rid of these variables. So a small little adjustment here. Let's go ahead and get rid of these. Perfect. So with this change, I also realized that we're not going to need the look direction. So we can go ahead and get rid of this. So what we're really only going to need is yaw and pitch. And I just decided to make this calculation inside of the getMatrix function. Alright, so from here, we're just going to want to initialize this to 0, 0, and -1. And so we're also going to want to get rid of this right here. And we're just going to want to make sure this increments by position every time. So what basically is going on here is we're creating a quick look point vector right here. And by default, we're setting it equal to -1, which is the forward direction. And then based on pitch and yaw, which is our mouse position, we just rotate it. And so we're no longer taking the offset mouse position, and we're just taking the raw mouse position, which is yaw and pitch at this point. And then after we rotate our vector, we just add it to our position like we would normally do. And to make this code even cleaner, we can actually just say look point dot add, and we can just say position. And obviously we would pass in the vector that we want to apply this change to. Alright, so this is a small little improvement from what we had, but effectively it should do the same thing. So now let's go ahead and run this. Alright, so as you guys can see, we can move our camera with WASD, which is perfect, and we can also look around freely with our mouse, which is amazing. Now, obviously, in video games, you're going to want to maybe put a cap to how deep, or not deep, but how far you can look down. Obviously, if we look down too much, this will happen. So you can just say, hey, if pitch is over 90 degrees, just lock it where it is. Obviously, you wouldn't want to do that with yaw because we should be freely able to look around in the X direction. But yeah. Also, there is one slight problem that you might notice if you're running this on your own computer, and that is that if we're looking forward and we use WASD, it's perfect. But if we turn around backwards and we press WASD, you can see that it's inverted. And that's because WASD is relative to the world. It's not relative to where we're looking at. So if we were looking at this direction right here, you would expect that W would make it go forward. But it does not. It goes forward relative to the world and not relative to where the camera is looking at. But in simple words, to fix that, all we would have to do is go to the translate function and make a new vector here called offset, or you can call it whatever you want. And we would just pass in the XYZ. So now, as you guys can see, this vector holds our offset, our translation. And what we need to do is we need to rotate this translation so that when we add it to our final position, it moves our camera in the correct direction. So all we have to do is say offset dot rotate. I'm going to rotate around the Y and not the X. You could also do X, but I'm just going to do the Y. I'm just going to go ahead and copy this. And we're just going to make sure this is Ya because we're rotating around the Y. And make sure we put offset here. Alright, so finally we're going to want to add this by the offset and not just XYZ. And if we go ahead and run this, you guys can see that we have a fully functioning camera. So wherever we're looking at is where we're going forward. So if we're looking here, we're going forward here. So this is great. Okay, so this is really all there is to making a camera. Hopefully this tutorial helped you out. If it didn't, because I know from personal experience, there could be many mistakes making a camera. So if you have any mistake or anything went wrong while you were making your camera, leave a question down below in the comments and I'll try my best to help you guys out. So yeah, as you guys can see, it's a pretty simple class, some pretty simple code, and there's a bunch of different ways you can organize this code. As you guys can see, I chose to put all my camera stuff inside a camera class, but there's a million other things you guys can do for your projects. But anyways, I'm gonna leave that up to you guys. But with that said, thank you guys so much for watching and have a great day.